AMD maybe not. All right, let's get this started. So we're going to be going over Docker, and Docker is software container platform. So what we need to ask ourselves, first, I guess in the room, are you guys familiar with what containers are? I know you are to a degree, right, Travis?
Yeah, I am.
Yeah. So containers they're sort of like VMs in the sense that you can encapsulate your application within them, but instead of being the full operating system, you have just a subset of instructions that run on top of the already existing kernel, and they run in isolation from each other. So you use the same kernel for all of your containers, and your application is isolated from each other. So what this does is guarantees that it'll run the same regardless of what machine you run it on, so long as you have Docker installed, and that abstracts away the containers for you. So that brings us into what is Docker, which is the container platform. For developers, it eliminates it works on my machine for the most part. There's still quirks that always come up. Operators use it to manage apps side by side in isolated containers. It allows you to get higher compute density, so you've got one server with 16 Docker containers on it, and if it can fit another smaller Docker container on it, it will. So through the orchestration process, you can get that density of applications. Enterprise use it for their deployment pipelines. It's a way to build out these artifacts that guarantee the same consistency of the application from QA to staging to production, or any other steps throughout that process that you want. It's supported on Linux and Windows natively, and it sort of shims its way into OS X via VMs. So you still get Docker, but there's a layer in between. So any questions on that? Excellent. All right, so pro-con list. Encapsulation, like I said, your application is sort of isolated away from all the rest of them. And as that happens, when you build these images, you can use them throughout the deployment pipeline. It's really fast, so other than the VM implementations, when you're doing local development, that slows things down a bit, but when you've got it running in production, unless you're doing something crazy that's like you're running into bugs against Docker, it's going to run pretty quick. And it's portable, so you can take it from staging, QA, production, a Windows machine, OS X, Linux, wherever you need to go. The downsides here is security to a degree. Like I said, you're running on the same kernel, so there is some shared software there. The memory and everything is isolated into its own resource allocations. You're sharing the code that's essentially on the OS, so if something has a vulnerability in there, that vulnerability is shared between all containers. You're not truly sandboxed away. So,
but your file system is, right?
Your file system is, your resources are, there is encapsulation going on, but if some vulnerability was able to get into one container, it could get into all.
Right, how about, I guess this is more performance related, but noisy neighbor, sort of like, does that bleed into, like, can containers have limits on and contain?
Yeah, you can definitely contain so each container that you spin up, you can allocate specific amounts of resources that they can consume. So you can prevent the noisy neighbor problem by restricting them. If you don't do that, though, yeah, you could step on each other's toes if you saturated the network. So,
right.
Yeah. Anyway, it's open source-ish. So heavy on the ish. Docker had recently rolled out a big software update without consulting the open source community at all. They said, hey, here's this big thing merged into, stable, and enjoy. And people lost their minds. This was the whole Moby thing, where all of a sudden there was this big amount of code that people didn't want in their code bases. So people were threatening forks and all of this. So they came out with Moby as an answer to that, to be like, okay, if you want to build an alternative to Docker, Moby is what you build your Docker on. So
is Moby maintained by them?
Moby is not maintained by them, and that's the key. It's a completely open source, completely community-driven project that everybody has to do, pull requests against,
and they
including them.
So it's a hard fork.
Yes. So Docker is now based off of Moby.
Okay.
Oh,
so yeah.
Gotcha.
Right. So that's the open source-ish. They are a for-profit company. They're going to do whatever makes their bottom line best. Bugs, not really a huge problem. It's any software you use can have bugs. It's just it runs across so many different platforms that it's more likely to run into bugs, just by sheer coverage that they have. All right, so let's talk about the basic anatomy of Docker, and at least the basic anatomy we're going to use. So we've got our images, we've got our containers, our services, swarms, and stacks. So images are what you build your container into. So you want to load it up with your application. You want it to have, Nginx on it. You want it to have this version of Linux. All of those are different layers in these images. So all containers are built off of images. So once you have an image built out, you're satisfied with the state of it, you can spin up a container, and that container will run, generally speaking, one application. So it'll have a lot of other things working on there, but the application in a LAMP stack would be Apache. In a LIMP stack, it would be Nginx. In ours, it's the Go application itself, in this example. When that application or service crashes, the container goes down, and the Docker machine will restart it automatically for you. So it's got some resiliency built into those on its own.
As far as applications, that's a pattern, right? Like you can run 10 applications in a container if you wanted to.
You can, but it's sort of an anti-pattern because...
Right, that's what I mean.
Yeah.
Like you shouldn't, and they say
right.
You should use... Okay.
Yeah, because if you do that, then you have to have Docker watching something, whether that's a log file, like tailing a log file. It's got to be aware of the life cycle of something. So generally speaking, one application per container, and you're doing it right.
Okay.
So next step is services, and services are really just containers, but they're containers that are running on top of a swarm. So a swarm is... it spans multiple Docker machines. So if you have, 6 machines in production, these are physical machines, and you've got a swarm that spans all 6 of those machines. Each of these services can join that swarm, and those services are just a single container, or a container per machine. And then you've got stacks, and stacks is where it all sort of comes together. So I'm sorry, the stack was what I was referring to. Stack span machines, swarms encapsulate all of that. So this machine, these 3 machines will join a swarm, and inside of that swarm, inside of those machines, you can have a stack. And the stack would be like your production website. So say you have, Google.com, the search engine. That would be one stack. And then you would have another stack for Google Images, potentially. Another stack for whatever other applications you run.
So you could have one swarm with multiple stacks?
Yeah, so,
okay.
And I didn't display that here, but yeah, you can have n number of stacks on a swarm.
Okay.
So, but that stack has to span multiple machines to become a stack. That's what makes it a stack, is being across those machines. So in this case, we can see we've got 2 swarms here, a production swarm and a QA swarm. 6 machines in total, 3 in each swarm, and 2 stacks. So the reason I have these displayed like this is you can see the allocation of the services is AB, AA, BB. On production, it could be AB, 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 or any combination of those. Those are not something that you generally want to choose. You want to say, here are the machines, allocate yourselves to them as, as seen fit by the Docker swarm manager. So, and that's basically what we have set up here is reflected in this image. So we'll dive into building that. So we've got our develop and deploy flow. Little preface here is you can do whatever you want with Docker, pretty much. This is one flow that I've come up with for small teams or single developers to be able to get Docker running for them locally through any QA and staging and on production as well. So with this, you can scale this up to n number of machines, be it a little manual unless you write scripts for it. But this is a great way to get you started. So there are several steps in this life cycle, and I'll just walk through them. You build your image and run your local container. These are a local image and a local container just for you as a developer to use. And then you can make your local changes. So what this allows you to do is kind of like bringing up a virtual machine or bringing up WAMP or LAMP or whatever stack. You make changes locally, go to your browser, view it. Make changes, browser, view it. There's no compilation process. It's just live reload. Anytime you need it, it's available. Once you're happy with that and you're ready for it to go up to QA so that your QA team can look at it, you're going to, in this case, compile a static binary and build a deployment image. If you're working with PHP, say you're working in Drupal or whatever you're doing, you have to do Composer. I assume Drupal's Composer based now, with Symfony being in it. So all of that Composer packaging would happen in the building of the image. So you would end up with the state of your application, all dependencies installed in inside of that image. So now you don't have to worry about your build process failing when you go to ship it to production. It's already built once.
What's the difference between a static binary and a deployment image? Are they one
Well,
and the same, or?
Compiling the static binary is like doing the Composer install stuff. You do
this
that
is your
first.
example for your Go application.
Right, yeah.
Okay, got
So
it.
it's the same thing. It's just in Go you compile a static binary. In PHP you
Right.
build your assets and bundle them into the image.
Okay.
Once you have that, you can tag your repository with the latest image and push it up to the registry. So the two phrases here, this isn't a Git repository, it's a Docker repository and a Docker registry. So you can host your own private registries that have your own private repositories, and repositories host images. So those are like the three keys to that. A registry can hold multiple repositories, it can hold multiple users. A repository can hold multiple versions, multiple tags of that image. And we'll look at that a little later. Once that's up on that repository, up in the cloud or on your local machine in the back, you're ready to use that as your artifact through the deployment pipeline. So anytime that you build out your QA stack, you're going to grab that image, build a bunch of services out of it, and give it to QA to test against, and they'll be able to, tell you if anything's wrong or if it's good to go to production. If they say it's good to go to production, you're going to take that same image from that repository, put it on the production stack, spans all the services, and your application's on production. And you didn't have to recompile or rebuild any of your assets. You didn't have any risk of, maybe the third-party vendor app or vendor package you were using had internet connection issues. GitHub was down, so nothing installed. And if your deployment pipeline wasn't properly set up, at best, it just didn't build. At worst, production's down because it failed to build maybe when it was on the box itself. So this reduces all of those risks. What that ends up looking like is this. So basically just flows all the way down through all those steps I talked about to the QA stack portion. If QA says this is not ready to go, you just kick it back up to your local changes and keep going through it. So once it's good to go, it goes to production, and then that's where your feedback cycle goes to local changes for new features or point releases or hotfixes. So it's pretty safe and it's a pretty simple process. But it allows a single developer or a small team of developers pretty rapid access to a reliable deployment pipeline without any additional software.
I think you're going to talk about this later, but the differences between QA and stage and prod, that's handled it. How do you handle that?
Yeah, and I'll get into that here in just a minute. So, actually, where is that? First, let me go back a step here. So we go through this. Okay, so before we do anything, we need to build these machines that these stacks will go on and that the swarms will be built on. So right here, what I've done is, I've actually got a mouse for this.
Take a note. I would separate this into multiple slides.
Yeah.
Just because it'll be easier to read, and you can walk through like the first one.
Sure.
And then talk about that.
The
Talk
second
about the
step,
next step.
yeah.
Talk about that.
That's a fair point. So these 6 lines here, the top 3 build the QA machines, and the bottom 3 build the production machines. So all they're doing is going through Docker machine, which is installed when you install Docker, running create, specifying a driver, in this case VirtualBox, It could be AWS EC2. It could be DigitalOcean. I think it can be Linode with a third-party driver. They don't support it out of the box. And then you give it the name of the machine that you want.
Okay, so the driver, it allows you, they have just, Docker has
It
provided
completely
drivers for
abstracts
all
away
these,
the machine
yeah.
creation.
Machine-
You still have to do so if you're building this on AWS, you're going to have your security group set up, your ports all set up. You can do a lot of configuration of that through here, but you need to have your environment set up to allow for this. And that gets into our next step where we set up our swarms. So we run this Docker machine SSH, and really what that's saying is we're just specifying the machine and piping in a command to it. In this case, we're initializing a swarm. We're taking the IP address of the QA manager server as the one to advertise to the rest of the people joining, and we're going to put it on 2377. You can put it on whatever port you want. This is the port you would have to open up in Amazon, at least between the machines, so they could talk to each other.
So you need a box to manage your containers,
You need a box to manage your swarm.
your swarm.
Yeah.
So that's the requirement of the swarm.
Yep.
Okay.
The swarm needs a manager, and that's the one that facilitates, you're allowed to join. It presents a token, and you can take that token and have other machines join with that token. You can also have multiple managers, so you have resiliency there.
Okay.
So if a manager goes down, you can rebuild the box and use it to join that swarm again with a manager token.
And
So
when you deploy an image, you deploy it to a swarm or to...
so you do. You deploy to the swarm, and we'll get into that step here in the next slide. So this one right here, what this is doing is taking the result of Docker swarm join token worker. This could be worker or manager, and that basically just gives us a token, just a string, and we're grepping for that token, and we're grabbing it from that segment and saying this is the token and assigning that to the variable here. So we now got our QA manager token, and we can use the QA boxes 1 and 2 down here, and we can say Docker swarm join, specify that QA manager token, get the IP of the QA manager on port 2377, and they've now joined the swarm. So you build a swarm, grab the token, join the swarm with 2 other machines at n number of other machines, and now you've got a swarm up and running. And then we do the exact same thing for prod. Just swap out QA for prod, and it's the same code. You could dry it up if you want, but it gets the point across.
Are these breaking changes if anything goes wrong in here, or is it going to keep going?
Yeah, this would be a breaking change. So you'd have to have your machine set up first in this scenario and ensure that they're all good, and then you can move on to deploying.
Because you're creating them in the beginning, but there's no stop.
Right.
If something goes bad.
Yeah, these are sort of pets in a way. These aren't like really repeatable process. You could refine this script and make it a lot more robust and resilient, but this is sort of a get it out the door thing.
This is just getting your server environment in play,
Yeah.
right?
Mm-hmm. Now you could have a different server on its own stack doing its own thing that's totally responsible for building these machines for you.
Yeah.
Right,
But then who builds
you're-
that machine?
Right. At some point, somebody has a pet somewhere.
Right. Totally.
So we're just making these the pets for now.
Right, yeah, makes sense.
All right, so the next step is for when you're working on a small team or large team, you want to inject your authorized keys. So this is saying Cisco has the ability to SSH in, Travis, anybody I want, not random. That guy's not trusted.
At least not in production.
So you just, cat the output of your provision authorized keys, which you can set up within the repo. It's a non-git tracked file. And then you just pipe that into Docker SSH, which pipes it into the authorized key of the SSH of that machine. So anything in red here is happening on the machine itself. So we see that 6 times, 6 servers, 3 prod, 3 QA. All of them have the SSH keys they need. So now anybody who has a system can SSH into those machines and check the health and status of them. You could also say, I don't want my developers going in there. I want the deploy server I have to be the only thing that can SSH into it, and set it up that way. But
So the reason you would have SSH keys is just to kind of poke around health and debug or whatever.
yeah,
Because your deployment cycle will never need that from a person.
right.
Okay.
Yep. And when you do create these machines, it creates a SSH key for you and injects it on its own. So you're just adding to that list.
Right. So it already has a system-to-system communication straightened out.
Yep.
It's just not if you want individual users being on
Right.
those boxes. So this is optional, essentially.
Totally optional.
Okay.
Yep. All right, so let's go back into here. All right, so we're going to go step by step. First, we're going to go through build image and run local container. And I've set up some files to sort of streamline this process, and we'll dive into them. So the first thing you need is the Docker Compose file. Docker Compose is a tool for defining and running single or multi-container Docker applications. It's basically the description of what that container will be. Then you need the Docker file. That is sort of some internal things. You can add files with it. You can tell it what image to build from. And you can run the application from there. You can do a whole lot more too. But that's what we're starting with. In our case, we're going to be specifying an entry point script. So when the container itself has built and it's actually running, kind of like an OS would run, it's going to dump you into the entry point file and do anything in there, and that's just a bash file or a Python file or whatever file you want to execute. That'll be the entry point script. And then we have a build script, and we'll get into what that does. So
Is compose in this case is different than composer.
right,
Okay.
yeah, and it
That,
can.
you might put that in there, but
I guess I could.
Yeah.
I won't necessarily be giving this to a bunch of PHP developers, so
Yeah.
that's the other part of it. Although, let's be honest, like a lot of people.
people are
develop
familiar
PHP,
with it,
yeah.
I think.
So
They might
the amount of times I type Docker Composer,
Yeah.
so frustrating. It's
It's
so
one of those, right?
frustrating.
Yeah.
So you dump in here on the first line, you specify the version of the Docker Compose like syntax. 3 is what we use. 3 supports swarms, so it's the latest and the greatest. Use it, kind of thing, and it's stable. So in here we've got our services. These are what will spin up containers. So the first service we have is web, and you'll notice down here we've got a network called WebNet. Anything that joins the WebNet network can communicate with other services by their name here. So instead of saying, ping 192.168, etc., you just say ping web. And it's like, there you go. And you can do all your cross communication of your containers using that. This is a development specific thing I'm doing where I'm mounting my volume. Right now I've got it as an absolute path to give you an idea. Basically I'm going into this Docker folder and mounting everything that's in here into this Go folder. Anybody here familiar with Go at all?
Slightly.
Yeah. So Go has this weird thing where you have to have a Go bin and this Go specific directory. Basically, this is what it is. So I'm dumping my files into this namespace under, and I've got hello develop Denver for when we do the talk. Basically, that just puts all the files where they need to be inside of the container and keeps them in sync. So any local changes I make happen inside the container as well, and vice versa. If I went in and made changes in the container, I would see it on my local machine. All right, so the next thing we've got is our build node. So what I've done here is I've given a context, and I'll show you my file structure here afterwards, but basically Docker files must be at the root of your application. That's at least as far as I can tell. And in order for me to segment things appropriately, I created like a provision folder and put my Docker Compose YAML in there. So this is just saying, hey, actually look up a directory for that Docker file. So it just sets it up to do that, and then we specify the Docker file. And this is the file that it will use to build out the image for us. And then we're going to call it this name. So this isn't the image we're using, it's the image we're naming our image once it's built through this process. And then same for the container name. It's what we would want the container to be called. This gets into what you were talking about with QA and prod being different. We can specify a .env file or an environmental variable file. And what this will allow us to do is things like passwords, tokens to AWS, secrets, all this sensitive data does not live in the container. It's injected into the container once it builds from the image. And that's how we can use the same image on QA and staging and prod. They all have different environmental variables. you know, you don't want to use your authorize.net live key. You want to use the sandbox key. So this allows you to do that through the stages. And then we've got this ports node. So what this is saying is take 80 of my whatever hardware machine is running this container and port forward that to port 3000 inside the container. So if somebody hits up against this machine's IP address, it goes to port 80 via HTTP and then forwards into 3000 into the container. So you basically end up in the container by just hitting this machine's IP address. And all of this port 3000, everything, this service name web, all runs on the WebNet network. You could name this whatever you want. It's any network name. It's not anything specific. And we just specify that we want this network to be built as well so that this can connect to it. So the web service can connect to the network.
So if you had multiple services, you would just have another line below.
Yep.
It's like API
So,
or
yeah,
whatever.
so it'd be along the same line because it's YAML.
Uh-huh.
So it would be tabbed in right above networks, and it would be called Redis or whatever you want to call it.
Not Redis.
Debatable.
We can argue that.
We can argue that, yeah.
Are there specific permissions on the volumes that you need to have?
Yeah, so I did have to do some trickery with my permissions locally. I had to expose things to group permissions because user is my system, group is Docker. Anything else that wants to read and write that, so you have to allow them to write all those files.
Okay.
And you can tune that as you want.
Similar to like a Vagrant.
Yeah. Again, this is running locally, so I'm not too worried about it.
Mhm.
But those are the kind of things you want to sort of raise an eyebrow about in production. But fortunately here we don't have to worry about it. So that's a compose file. Tells you exactly how you need to build your container. So then it'll run and dive itself into the Docker file. So the Docker file is the description of the image. So we have the description of the services. This is what the image is going to be. So right here we've got from. And what this is saying is what image do I build this image from? So it's kind of like a related or a parent image of this. And in my case, I'm using Golang, and then this colon here specifies version. Whoops. Version. So this is the image. Golang is the image. 1.7.6 dash Alpine 3.6 is the version. Docker Hub does a bunch of prepackaged images, and their namespaces will often align like this. So what this is telling us is the OS is going to be Alpine. Think of Ubuntu or Debian. Alpine is a much more minimal version of Linux. That's like bare bones. It's a couple megabytes when you boot it. We're going to use 3.6 of that. And on top of that, it has Golang 1.7.6 installed, which brings it up to like a couple hundred megabytes, which is why we don't use this in production. We want these containers to be as small as possible. So we'll see what we do in production, but basically we just use Alpine. So now we've got Golang installed. This could be PHP, it could be Nginx, stood up, it could be Apache, whatever. This is specific to what I'm doing. APK is like the package manager. It's like apt-get or yum if you're using Fedora or Ubuntu. We just update and we add Git. So we're bringing Git into the mix as well. You can argue, and you would be right, to say, well, if you want Git, you should have that be its own entire image, and then base this image on that image that has Git installed on Golang, installed on Alpine. That's how you're supposed to use containers. Or images. In this case, I was just quickly adding Git in there. Mm-hmm. If this process failed, then no image gets produced, right? So there's a point of failure here.
Yeah, but this is just a production of the image, so like
right, yeah.
this
So
only
the
gets made
local
once
build image.
before you go anywhere, like
Right.
where it matters.
Yep.
Okay.
So then we take our entry point file from our local file system, and we put it in that same path, so we have access to it. And then I just threw 777 at it, so anything can execute it. It could have been 775 or 770. In fact, 700 probably would work. And then I specify this entry point command. And what this says is once the machine is booted, go ahead and run entrypoint.sh. So then that dives us into the next thing we look at, which is our entry point script. So this is the bash script that runs the moment this container is ready to operate. So it's going to cd into that root directory, This is going to install something called gin. This is how I get my live reloading in my application. PHP and Nginx, you wouldn't even have to worry about this step. That would just be, run Nginx, good day, run FPM. I also got my dependency manager. Think of this like Composer. And then I cd into this directory and I do dep ensure, which is like Composer install. Boom, all my dependencies are on that machine. So, and then I run gin, I specify my application, and I tell it that it's going to be running on 8080, and I run my script. This is just like saying, Nginx is up and running, and now you're ready to go hit against it.
So is this is still before the image is created and saved?
This is after. So the Docker file, once you say Docker compose build, it'll go through here and build this, and then when you say Docker compose run, the moment that container physically comes up from that image, it'll then enter the entry point. So
Okay.
this is a container.
So then, aren't you introducing your dependencies? You're saying that when I move this to production, it's going to install.
This is local.
Okay.
So I'm not worried about it for local.
I see.
This is strictly a sort
Makes
of cheater
sense.
environment.
That's
and
semi close to prod.
Semi, yeah. It's pretty close except for all the bad things.
Whatever.
So next we have our build script. So this is what we want to do to build out that local image and then container. So all it's doing is saying, get into the proper folder and then Docker compose kill. That'll look at that Docker file and it'll find any containers with that name and kill them. And then it'll also remove them. So in Docker, if you just stop a container and create a new one, now you have two containers, one stopped, one running. And you can get a lot of bloat in Docker that way. So it's good practice just to go in and clean up after yourself. Anytime that you're building a new container, make sure your old container is gone, unless you want a lot of containers for some reason. This next one is just wrapped in an if statement. It looks for any images, also specified in the Docker compose file. That's this node right here. And it says, all right, look for it. If it exists, basically if it's not blank, then go ahead and RMI, which stands for remove image, and then the image name, and the image is cleaned up as well. And then we run our build, Docker compose build, and Docker compose up -d, which stands for detached. If you don't do the -d, then the container comes up and the standard out is what you see on your screen. So if you control C off of that, so say it's like logging something or errors are throwing, you wanted to see it, you can do that. But the moment you control C or don't detach from it but cancel it, your container goes down. So I do -d just so it stays up and running. And you can also do Docker logs and specify that container name, and you can see all the log output from that standard out. So, all right, so we've set ourselves up to where we can now make all the local changes that we want. So we've got our local container, which I'll demonstrate here in a moment. And inside of Go, we've got package, think of this like a class. We do our imports, think of those like use statements, and then we've got our functions. We got one called handle, and we're going to insert one called bask. Go throws itself into the main function when it runs, just the way it works. And we brought in a router up here. So this is just an HTTP router. We can register endpoints with it. So we've got one called, /, that's your home, that goes to handle, goes up here and simply writes, welcome to DevHour. Then we're going to add one called bask. That's going to go to the bask function, and you're going to get this guy basking in his glory. And then you're going to listen and serve on port 8080. Now, if we go back up, or not. Oh, I guess over. Right here is port 8080. This is what we've told it to proxy to. So gin is basically just a live reload proxy. It runs on port 3000. That's why you'll see that we specify port 3000. This is to go to gin, and this is to go to our application that's running in Go, which is this. So just a bunch of port forwarding going on. We specify our router, which is this Chi router, and we can see it. So let's demonstrate that.
Sure, it's not shy.
It's Chi.
Okay.
Get your Chi on. All right, so 192.141. All right, so we hit against the root route. If my machine was online. There we go. So it says, welcome to DevHour in the world's smallest font. Now if we go to /bask, we get a 404 not found. So I can go in here and I can add that route in just a minute. And this is something ideally you'd be able to see, but it's all
How are
right.
you gonna do this stuff live? You're just gonna have your laptop.
Yeah, his laptop
Yeah,
is going to be
I'll have an
straight.
appropriate
His
setup.
idea was to put his laptop into a TV,
Right.
Yeah.
but it didn't work because of our capture stuff.
But how you? So you're bringing two computers.
No, we'll just have one, and I'll have multi-monitor on it. So
Oh,
I'll
okay.
just control it over there, and then
Yeah.
move my stuff over when I need to.
I was gonna wonder how you got this IP then through their router.
Oh no. Well, this thing's frozen, which is great. Hang on.
Hey, is this where you're switching into the live demo?
This would be a quick live demo if my editor was not crashing.
They say Macs don't break.
Everything breaks.
We were lied to.
All right. So what you can't see is I'm putting in these this handler, and
The Zoom, you'll see it.
it's so quick though. I'm not even gonna bother. Basically, you get to see the end result, which demonstrates that this actually works.
What have you done?
So there he goes.
What
so
did you just do?
I made my local changes, didn't do anything else, refreshed, and the live reload took place. And this
How? I'm sorry, man.
and this is what you get to see.
Are you
So
mounting your files?
It's so the way I'm mounting
They're
them
already synced.
Where did you
is
define that? Maybe I missed it.
right here in the volume.
Oh, okay.
Yep.
And that
So
once again is a local thing only.
yep, local thing only volumes. I mean, you can use it on a prod image if you know what you're doing and you know what you want.
Right.
But I'm using it specifically here so I can get this,
I see. Got it. Yeah.
real quick live feedback.
This is the same as Vagrant. Like if you
Yeah.
use Vagrant.
Favorite
Yeah, you're
shares.
using shared folders. Yeah. So,
Because you had some issue with that in the past, right? When you first were working on this.
yeah, I had to figure some stuff out. So anyway, he can mask
Yay.
because he's
Yay.
earned it.
We'll have to
all
use
right.
the table flip.
So that's it for making local changes. You can do that as many times. Should do a table flip. And then we've decided we've done all the work here. That's the feature request was to Bask, and we've succeeded at that. So we're going to compile our binary and build our deployment image. This will deploy to QA. It'll deploy to staging. It'll deploy to prod. It's a simpler setup. You got your compose file, your Docker file, and your build script. So this is where we get to see how minimal this can start being. So we've got the same web service, got the same network. We're forwarding to 8080 instead of 3000 because we no longer need that middleware that proxies. And we're saying that this is going to be called untagged. It's just an image name that we can use in our later steps to actually tag off of this image. And we're going to specify a Docker file deploy image build. It's a very long, lengthy name. Feel free to come up with shorter ones. So the next step is we dive into this Docker file. So we get in here. All we're doing is specifying Alpine 3.6. It's about a 3 to 5 megabyte size, and I don't remember exactly. Pretty small image when all is said and done. We're taking a compiled image and we're throwing it in SRV, which is that's where I decided I wanted to serve out of. And then we're running that compiled application. So in our case, or in the case where it was PHP, you would just add all the local files in there. You would do your Docker or your Composer install stuff at this point or within another step if you wanted, and you would run Nginx. And then anytime you hit up against Nginx,
Your main is just a binary that you've already created
Yeah,
separately for
yep.
this.
Yeah, and I've got a compile script, but I don't want to show that right now.
Yeah.
Basically, compile your application in whatever way you see fit
Whatever workflow.
and run it. You know, put
Jenkins could be doing that. For
Jenkins would
example.
definitely be the thing to do that, right?
Something like it.
Yeah, so get your image or your application on the image in a state that you want it in, and then run it. And again, this CMD will only happen when the container is built from the image. So it'll know, okay, I've got a set of commands that says I need to go and do this when the container comes up.
How is that different than entry point?
If you went to entry point and entry point said ./srv main, it'd be the same.
Okay.
This just, I don't need to do a bunch of stuff here, so I just run the single
Okay.
command.
Okay,
Yep.
got it.
All right, so, and that's it. So then our build script runs this compile script. This could also be like, you know, your composer installs stuff. It's debatable whether you want that to happen in a container or you want it to happen locally, but basically the result is the same. The files you want are inside the image. So you do that compilation step or that build process step, and then you go ahead. This is the same stuff. This is removing any of the old container, removing the old image if there is one, and then it's going to, and -f specifies the file. Since it's not called docker -compose.yml, we need to specify and tell it which one to listen for. So we're specifying to listen for this deploy image build YAML, and then we're just saying build. And you know, we don't say up, we don't do anything else. It's strictly built the image. So there's no container associated with this, just an image. All right, so now we've got our image.
I thought there was a Docker compose kill in the previous.
There was, but again, no container, so no need to kill
Oh,
it.
I see. Okay.
Yep. So I'm strictly doing an image purge.
Okay.
Yep. Yeah, kill, start, stop, stuff like that is container specific, and no need when we don't have a container. So now we tag the repository with the latest image that we just created, and we push it up to our registry. So we do docker tag, we take this untagged image that we just produced. In my case, this is the namespace up on Docker Hub. And then I've got : latest. So latest being, you know, that's assumed to be the latest version. Really, we would tag two things here. We would tag the version and we would tag latest. And those two would always happen with each other because you always want to keep track of your versions along the way. And then we push that image up to our repository and just specify the image name. And it's up on Docker Hub and ready to be
So
used.
the : latest just specifies the Docker, but this is the latest image.
Mhm.
And then normally you might have low develop Denver : 1.5.6.
Right.
Or dash 1.5.6 or something like that.
Or whatever.
Whatever you want to do with your images.
Right.
Okay.
And you would push both those up to Docker Hub at the same time. Or if you want to get particular, you would push the version up first and then the latest. Because pushing latest itself could kick off a build process or a deploy process if you wanted.
Wait, so explain again. You're pushing two things. You're pushing two images.
Yeah, so you've tagged two images and now you're pushing two images. Tagging takes a specific image and makes a new image with that specific tag.
I see.
It's a replica of that other image. They're both still existing on your machine, just different tags associated with them. So you push that tag or those tags up to the repository and you're ready to go to your QA stack. So I've got them both in the same one. I might spread that out for the talk, but basically we're going to deploy our stack to QA in this instance. So this is where we have to do a couple things directly on those machines. So SCP is SSH copy. It's just a way to get your file from your machine onto a remote machine. And we're going to take this .env file from QA, and we're going to target the QA manager, and we're going to put it in the home docker.env file. So this is the directory of the home directory of the Docker user on the QA manager machine. And this is where the managers come in. Managers are in charge of doing the swarm action. So all files need SCP'd into that. However you want to get those in, that could be handled by a build server or locally like this. And you don't need to use Docker machine. You could just SCP because we've added our SSH keys. And then we also move the YAML file for our deploy. And so both the env and the YAML file are on that manager machine. Again, in the Docker home folder as this file name. And then we're going to say, all right, let's go ahead and SSH into the QA manager and run docker stack deploy. Specify -c for the file. And the file is going to be our compose file. And we're going to call it this name. And that's it. It now looks inside of our, so if we go up, or I guess, let's see, I guess down. I might swap those two, but no, I think it's fine. So let's look at the internals of this Docker compose file, because it's going to be a little different since we're dealing with a swarm. So if we look at it, same version, same service node called web. This time we're specifying this is the name of the image. We're going to pull in that .env file that we SCP'd in. This is going to be all the QA key values. And then we're going to specify this deploy node. This is what tells the stack how to operate. So we want 5 of these applications running across the stack. So we've got 3 machines. 2 have 2 images, or 2 containers. 1 has 1 container. And then this is what you were talking about earlier. This is where we set up our sandboxing of these resources. So we say you can only take 0.1 of the CPU and 50 megabytes of memory from the physical hardware machine that it's sitting on. So you can adjust these to whatever you need it to do. Then we specify our restart policy. So on a failure, we're going to go ahead and try to restart it 10 times. Each time that fails, it's going to go ahead and wait 30 seconds. You could be arbitrary. You could say 1 second, you could say 0 seconds.
What's a failure? Is that a log?
So when you're in Docker, again, this is why I say it's 1 application per container, because I'm, in my case, running that binary. If that binary has a fatal error and closes, the Docker container goes down.
It knows. Docker knows that because I started that.
Yep, the moment that PID disappears, Docker exits.
Okay. And is that configured, or is that
Just the way Docker works, which is why it's 1 application.
How does it know
per
which
container.
PID? Just
Because
based
when
on-
you set CMD serve main,
Yeah.
it spun that up, registered that
Okay.
process, and watches it.
I see.
And the moment that that goes away, the Docker container says, I'm in an unhealthy state, I'm going to kill myself.
No, there's no other way to override like other behavior to like, no, I want to go look at some log instead.
You can tail the log, but the thing is, when you're tailing that log, if that application goes down, your log file is going to get an output to standard out, but the tail is still successfully running.
Right.
So as far as Docker is concerned, your container is in a healthy state, because tail was your indication of health. You know.
Right.
So you want
but
to
can
not
you customize that so it's not just its way of checking? So you
Not
can say,
that I know of.
correct the log and see if I see a certain word that's considered a failure.
You could have that log exiting standard out, and you could have another container listening to that and doing its whole job would be to say, okay, I understand that container is in an unhealthy situation. I'm going to kill him.
Inception.
So,
Unless
yeah.
it's unhealthy.
Which I totally wouldn't recommend doing that.
Right.
Right.
No, I see. I
Yeah.
get your point.
Right.
And this is why it's built around one application,
Right.
one service.
It's
one
all
provider,
within the
one
life
whatever.
cycle of this. And it's meant to be deadly simple to set up. You know, like once all is said and done, you're going to have a robust stack.
So other than tailing that log or creating a service that grabs it or something like that, how are you going to know when one service fails or one container fails?
So what you would do is you would set up another service next to this that is or actually there is a way to do it within this service. I forget what it is, but basically there are drivers for standard out, and you can have those drivers go to like sumo logic or
Or the
any
bug services that are.
It's not really a bug.
Well, but there's the ones that read the standard out. Like, I can't remember
Yeah.
where you're using at work, but there's services that run that.
Right.
That you control your entire map.
Right. And you can have anything, you could ship that off to a service whose job is to read and notify you
Yeah.
of any error. You know, like you could go to Slack, however you want to hook it up. It's standard out, right? You can do whatever you want.
Right.
Restarting, does that create a new container each time?
It does.
Okay.
So yeah, and this is also where pollution can start to happen on your production boxes or your QA boxes, is that container died, but it didn't remove itself and a new container started. So do that, 2,000 times at 5 megabytes apiece, and you're starting to see a lot of data getting eaten up. So again, in Docker, and I don't have it built into this, but it's good to go back and have a process for cleaning up old things. It could happen on a cron. It could happen, this could potentially kick off, it could notify another container that takes care of that for you. There's all sorts of ways you can handle it. And I'm sure there are potentially ways even within a YAML file. This is only like a small segment of what's capable within Docker Compose.
Are there like other policies that you can have as well? Or
There are a ton of policies, a ton of conditions. I haven't gone into all of them. Again, my goal with this was just like a pretty straightforward example to get you comfortable enough to ask those questions and like read the documentation.
Yeah.
Because Docker documentation is extensive. Like it's deep, deep stuff. So, but yeah, there's all sorts of policies you can set up, and I think you can set up your own custom policies. So we're having ports, and you're taking port 80 and forwarding it to 8080 again. And if you remember back in our code, we had our HTTP server listening on port 8080. So this could be 80. I just wanted to demonstrate that the port forwarding is happening and which direction it's happening. All right, and then we join WebNet, and that's it. That's our production image, or our deployable image. We can deploy it to QA and staging, etc. And because we're bringing in the .env file like this, and because we are SCPing a different env file depending on our environment during the deploy process, we can end up with the appropriate key values for that environment without having to have different images. So that's it.
I think I'm confused about the whole magic behind the networks.
Right. Yeah, it's a pretty confusing thing. It's setting up a virtual network
Yeah.
inside of the OS. So you know how VirtualBox can have its own network adapters?
Mm-hmm.
Same thing. It creates a network adapter, and these containers talk
Except
to each
for
other.
cross machine potentially.
Well, that's the thing. It sets up a network adapter on the system, right?
Right.
So then these containers connect to that network adapter.
Right, but
And they're
for the
all
container
part-
itself, it doesn't know that it's on 100 machines.
Right.
It just goes and talks to its.
Right, and there
Once
is
it sells,
so in
which is kinda
these
cool.
swarms there is a load balancer. So as you hit a URL, that say you've got an IP address and you pointed it to, in a weak system you pointed it to just the manager, and that manager was up. That request would go into the manager and it would hit a load balancer within the Docker machines, and it would say, all right, who needs this traffic? It can either round robin it. It can do it on, who needs the most, or who has the most available resources, things like that. And it can ship that command over to each of those individually. And this is where I can actually whiteboard. So that's nice.
Wooder. Whiteboard.
It's already on the
That's
whiteboard.
nice.
Dang, I can't see.
Yeah, it's up there.
So there's a couple different configurations we can do
Here's
here.
another view of it.
Oh, I see.
Oh yeah.
You're good.
Watch that crotch shot. All right. So you've got the browser. It sends a request over to essentially the manager. And really what's happening is it's hitting, and the manager has a little piece of software, a load balancer on it, that's saying, do I need to take this request? Or does either of these workers need to take this request? So it'll go in here, he'll make the decision, and ship it off to him. Now, if you instead had it go over to the worker has the same software and can route over to, this worker, if need be. What you should do is instead of having it go directly to an IP address for that specific machine, you should have something like an ELB, Elastic Load Balancer, or some other load balancer in front of it that will load balance itself, round robin style. That way, if one of these goes unhealthy, it can go away, the load balancer will handle these, and this will internally load balance between
When would you ever go
the
to the
machines.
manager?
The manager is also hosts the application. So just because it's a manager doesn't exclude it from doing the work.
Okay, so it can have containers also.
It can, and it does, unless in your Docker YAML file you say, don't go to the manager, go to only the workers.
Might be
So-
a good idea for allocator
And
reasons.
So
that's
you
another
could
policy.
have a manager, like say you want to notice any manager, you could have a manager running all 3 nodes or all 3 systems, but they're all spanning containers.
Right.
Okay.
Yep. But it is best practice to have a manager or a set of managers and workers, and you can allocate what you want each to be responsible for in the Docker.
Is the manager running in a container?
Yeah. Well, no. So all 3 of these are physical machines,
Okay.
or in EC2 they're virtualized machines. They're
Right.
whatever. Or in my case, they're VirtualBox machines, right? So
Right.
they're just VMs, and they have inside of them. Each one of these has, a series. So this one would have 2 containers. This manager would have 1 container, and this would have 2 containers for the service we've set up right now. And all of these would be working together. So this is the same application, this is, and you can have another container down here and another container here, and they're in their own little sandbox. So when this guy would be web, and this guy would be, the only thing I can think of is Redis. It's debatable if you want a data
Memcache.
store at all.
No persistence.
Yeah, Memcache would actually be a great example, because you can have Memcache in here and not worry about it, right?
Right.
But basically, it'll go here and decide which one you gotta run across. You would have to have these clustered. There's all sorts of, ways to set up your stack.
But the manager always knows the state of the different workers, right?
It does. So if a worker dies, the manager,
Can replace it.
well, it's debatable on how you want to get that signal out, but the manager can essentially be joined to. It runs the swarm. So if another worker comes up, it'll ask the manager if it can join with that token, and the manager will say yes.
Okay, so but it can also probably manage the scalability of that, right? Because it can look at the state. Or
I'm not sure about autoscaling.
the resources of the different workers.
I'm not sure how autoscaling works with Docker, and that's something I should look into.
Yeah,
Um,
that would be. I mean, that right there would solve a ton of problems.
right, and the whole thing, this actually really pissed off Kubernetes crew. Kubernetes is an orchestration software that solves all these problems. Thus, it's meant for like thousands of servers, right? Like with all these complex rules, you're not really just spinning up a couple machines with it. So they came out with this, and Kubernetes crew was pissed that they didn't use Kubernetes under the hood to do all this stuff, because it's what it's built for. So anyway, another reason why that open source-ish comes out, because like the community would have used Kubernetes. Anyway, yeah, and that's pretty much it. Anything else?
No?
Excellent.
I saw one instance of you have like this consistent manner of saying hello Denver,
Yeah,
but you had a DevHour in one of them.
I know, because that was the source code, and I
Okay.
didn't want to go through and like rechange
Gotcha.
all the things.
I just saw that.
You want to keep streaming while we give you some feedback, or?
No, I don't want that.
Well,
public.
no, stream it because you can, like, so you don't forget it. So
I can turn the
save
stream.
it.
I'll turn
Turn the stream off,
but
then
I'll keep
record it.
recording.
Okay.
Yeah,
Nathan and Chris, you guys have any?
Nancy, that was pretty cool. Appreciate you going into depth.
yeah, man.
Do you have any questions, you guys?
Nathan?
Nope.
Nathan, were you paying attention? We're gonna have a pop quiz.
attention.
Chris is already gone. He's like,
So-
"I'm out."
So I will say when we got to the second half of your presentation and we were diving into a lot more implementation than big picture concepts, it was harder to follow for me.
Yeah.
Agreed for it.
I have some suggestions for that too.
Yeah.
I'm gonna stop the stream.
Later.
Well,
Wait,
no, he'll
Nathan-
stay on. He'll